Welcome to our new unit, Unit 5 on nomenclature. This is Lesson 1, Video 1. So in this lesson we're going to review a little bit of our previous information from Unit 4. And we're going to define a compound and look at the types of compounds. And these are going to be very similar names to things that we did last unit. So a compound, if you recall back to the beginning of the year, we said a compound was a pure substance. So pure substance is something that cannot be broken down into its parts through a physical change. So this pure substance is a combination of elements bonded together. So this is where last unit comes together, because we talked about how different elements bond together to form compounds. And this compound has different properties than its elements part. So, if we look at something as simple as sodium chloride, table salt. Everyone is familiar with table salt. Table salt is sodium, Na, and chlorine, Cl. Well, we put table salt, sodium chloride, in our mouth. It really doesn't do a lot. It tastes like salt. It doesn't kill us if we take a little bit of it. Now, almost anything will kill you in certain amounts. Salt is toxic in huge amounts, but you would have to eat about 5 pounds of salt in order for it to really be fatal, and that would be almost impossible to do. Don't try it. But sodium and chlorine as elements are very toxic and very dangerous elements. Chlorine is a yellow gas. Sodium is a very soft metal that basically you can cut with a butter knife. It explodes on contact with water. So both of these things together form a white little solid crystal, and we can put it in our mouth and it really doesn't do much. So completely different properties than its elements parts. So we're going to divide compounds into two major categories when we go to do nomenclature. And these are the same categories we talked about in bonding: ionic and covalent. So in an ionic compound, we have ions that form the compound. So typically this is a metal plus a non-metal. So this is all review. So we have ionic bonding here, where we had transfer of electrons to form ions. So we have a metal, which are the positive ions, or cations, bonding with a negative ion, or an anion. And the word here that we're going to use in order to form these is charges. So that's our key word here. When we were talking about bonds, it was transfer, because electrons transfer. But here, when we deal with ionic compounds, they are going to be with charges. And we'll talk more about them in a little bit. Covalent compounds, also called molecules, no ions or charges involved. And these are between two nonmetals or metalloids. So we can have one metalloid, we could have two metalloids. And the word that we are looking here is prefixes. So these are going to be the clues that we use when we talk about nomenclature. And nomenclature is nothing more than a fancy word for a method of naming using a set of rules. And if you remember back to biology, we had a set of rules when we named all living organisms. It's called binomial nomenclature. And if you remember, you had kingdom, phylum, class, order, family, genus, species. Those are the 7 levels of naming, and they get more and more specific. So there's a set of rules for naming each one of those based on characteristics. So if we looked at the common house cat, its binomial name is Felis domesticus, or domestic cat, basically, house cat. And there is a system of naming for that. So chemicals are also going to have methods of naming using sets of rules. And a lot of them are based on the chemical formula for the substance. So a chemical formula is a representation of the kind and number of elements in a compound. So the 2 big words here are kind, and 2 phrases, the kind and number of elements. So the kind is given to us by the symbols of the elements. And the number is given by a subscript in the lower right-hand corner. So if we look at this substance here, NaC2H3O2, we can give the different elements based on their symbols of sodium, carbon, hydrogen, oxygen, and the number of each. So for Na, no subscript means that we have 1. So no subscript on an element equals 1. But we have a subscript of 2 after C, so we have 2 atoms. Hydrogen has 3, and oxygen has 2. This is going to be important when we go to name things, because we're going to see that some things have more than one possible charge when they're an ion. So this is going to be very, very important when we go to name things. If we look at one more example, let's say that we had this compound. And you'll notice that we have parentheses here. Well, if we have a subscript outside of the parentheses, we have to distribute that to everything inside of the parentheses. So we have manganese, sulfur, and oxygen in here. So there's a subscript of 2 on the manganese, so we're going to put a 2 there. The sulfur is inside the parentheses, and there's 1, but we have 7 of this group, so that means that we have 7 sulfurs. There are 4 oxygens in each group, and there are 7 groups, so 7 times 4, there are 28 oxygens in that group.